people think anything's a water truck. And when you get wet spots in the road, when you have water trucks that leak, it takes forever for those problems to go away. And a lot of times you're back there breaking your road crust, and you never really end up with a good project. And everybody kind of has to go through those scenarios. And today I hope we're alleviating a lot of that.
Good point. It's those small things. A leaking water truck, no big deal, right? So you have that issue to work on. We don't make money redoing things. Love it.
Yeah, the water truck is probably the most important part of the process. And you know, I always say the water truck driver generally wasn't the valedictorian of his class, so a lot of care and preparation needs to be taken there.
Sounds good. Good advice. So comments or questions to round open format. Anybody? Thanks for the tip, Denise. I know I was putting the camera on Terry because we shorted him earlier. He's the lead for the project, so.
I like this is Leanna Emmer with North Dakota LTAP, and I like the tip that I will share with counties when I'm going out to visit, as far as water trucks and having the water applicator to the front as to the back, and your explanation on why it's preferable to the front just makes sense. So yeah, thank you. Very good, Steve.
Thanks for the comment there. Yeah, watering is seemingly a simple task, but it kind of has some significant effects on things. So, and we're not dealing with a very big water window here. You know, I mean, with like soil stabilization, you may have a 5% window for water, and with, you know, gravel, we're looking at 2% at best. So it's a kind of a sensitive area.
I don't see any other questions or comments in the chat box, and everyone seems to be back in. So Steve, if we can turn it back to you.
Okay, well, thank you. Yeah, I appreciate the thoughts and questions. I guess I click on share screen, right? And doesn't want to. Oh, I guess I got to click. There we go.
There you go.
I'm sorry. Can you hear me all right, Dale?
Yep, loud and clear. Looks
okay.
Good.
Very good. Well, I appreciate the thoughts and comments there. And you know, if there's something that I go over here that you question at all, you know, or have any questions about, I'd really appreciate the question. I know I'm going through this pretty fast, but again, I feel free to interrupt. I mean, that's where we really get down to the nitty gritty. Well, this next section is on reclaimer mixing 4 inches deep into the compacted road surface. And if I fail to mention, I'll mention it now. You know, it's 4 inches compacted thickness. We don't specify loose thickness, it's compacted. And so we have to, when we, of course, run a reclaimer through that 4 inches fluffs up to maybe 5.5, perhaps 6, depending on moisture content. So what we're concerned about is uniform mixing depth. And I want to talk about the starting void and the ending hump, which may sound kind of weird, but I'm sure reclaimer operators can relate to this. and the 200-foot transitions in the specs. And this reclaimer alignment and overlap, we already kind of talked about that with chloride spreading. And the number of reclaimer passes, we have to make 2 passes on each side of the road. And the uniform mixing water is a critical issue here. One of the things that we see with any reclaimer is a certain amount of lean or on crowns, and it kind of depends on the tire pressure that you're running, how much lean you get. But there's quite a bit of weight in a cat reclaimer case here on the front tires that will make you mix deeper on the down crown side, and what you end up with is a bench, so to speak, or a lip where the 2 reclaimer passes intersect, and there's various ways to kind of cope with this, and I'm not sure which way is the best. I'm going to suggest one to vary tire pressure, but anyway, and this lean is not very critical when you're going down, say 10, 12 inches in a soil stabilization application. But where we're talking about going down 4 inches, it can mount to 1 inch to 2 inches, and again, depending on tire pressure. And so, one thing to do is definitely to check your tire pressures to make sure they're uniform, and then you may want to consider adjusting the front tire pressure, and maybe doing this on a concrete floor. And the 3.5-inch blocks kind of simulate the 4% crown, and so you put blocks under the up crown side to get the lean into the machine, and then you measure what the actual crown is, or slope, I guess, on the front bumper of these cat reclaimers. It's pretty convenient to do that with a cat machine. And you can you'll probably see that when you do that, that it's over 4%. So you need to adjust your tire pressure so that when you're on a 4%, the front bumper or frame is at 4%. So anyway, just this is just one way to try and counteract this issue with crown, grinding on a crown on thin lifts. What it means, though, is that every time you switch to the other lane, you have to turn your reclaimer around so that same wheel is on the up crown side. When we look at the voids and the hump created, when you do regular stabilization, where you're going down say 10 inches or something, when you lower your drum into the ground, you build up a pretty big berm in front of the drum, and so material is starting to come over the top of the drum before you move forward. When we do that with gravel, a 4-inch layer of gravel, what happens is the first thing you notice is that you're throwing rocks out the front of the machine unless your front door is closed, which I would suggest you close that just to kind of retain material. And as you start moving forward, you end up not getting a berm until you go down the road maybe 20 or 30 feet. And then after you get that accumulation of gravel in front of the drum, it starts coming over the top and falling behind the drum where it should be. Also, wherever you start, I suggest putting in a lath or some mark of some sort. Maybe a cone, a traffic cone, a candle, be another approach to make sure that you know where you started and stopped. After the blade gets out there and starts moving stuff around, it's kind of tough to tell sometimes. But you end up with this starting void, and when you get to the end of a run, you also have a hump. And, you know, of course, when you get to that end, you shut your water off. Of course, when your forward motion stops, you shut your water off, and you raise the drum out of the ground, and then you back up. And normally people will spread this berm out with their front door, going backwards. And but you have this void at the beginning, and it's you know, the beginning and ending here might be 1,000 feet away from each other, so it's not very practical to try and you know, get that material back down to this point. And I have a solution for that you might want to consider. But so anyway, you might want to smooth this hump out, but that doesn't really solve the void problem down here. And you know, one way to kind of deal with this is, I'll try and illustrate in this schematic, is that you have we've, you know, spread chloride down this side, the first lane, and the chloride truck either turns around or covers the second lane. And then when we come along with our reclaimer, you know, we have a void down in here, and he backs up and you know, and starts here again. And you could turn the reclaimer around here and go this way, and that way you'd have a void and a hump right next to each other, so the blade operator could have a chance to fix that void. However, another way to do that is to, like in the diagram, it shows the reclaimer starting, you know, on this side of the road, at this end of the road, and they're going in the same direction. And when you get on the other lane, you turn around and go that way, so that we end up with a hump and a void problem that are opposite each other, so the blade operator can fill in the void with a hump. So that's one way to do it, I guess. I show a roller behind this reclaimer for a good reason, and that roller, you know, compacting that material does a number of things. You know, one of the things it does is it starts this curing process, the chloride curing process, because it mashes all that material together and gets that chloride to spread out better within the compacted mass, so to speak. And it also gives the blade operator more of a solid platform to blade from, as opposed to trying to blade a bunch of loose material. And so, but you know, that's that one roller's compaction is you know, lost later by the fact that we have to end up blading all this over again, reprocessing this material. But it's I think it is important to have it there to start the curing process. Okay. One of the things that I think is, you know, important here, and Tom Oxford will, I'm sure, be on top of this, is to, you know, stop spreading chloride too late in the day. And there's a lot of work to do after spreading that chloride. So you may want to, you know, stagger your work team or whatever. With respect to transitions at the beginning and ending of the treatment, the drawings show a 200-foot transition, which, you know, I understand, you know, what we're trying to, what this is for, but I would suggest maybe, you know, making this 50 feet in the future. But, you know, there's a question as to how you're going to mill and blade this 200-foot section. You can't mill this thin out here. So what I suggest you do is take this material in the first 100 feet of this transition and basically move it ahead and start your milling here. And this is where your lath would go in the ground, or your candle. And then after you get done in the final blading, you basically move this all this mixed material back into this other 100 feet. So this is a starting point for your chloride application and for your mixing. You know, coming up with a chloride spread mix plan is kind of important based on, how much chloride you have in each spreader truck and how much water you have in your water truck, and what kind of a application rate or how much water you think you're going to have to add during mixing. The spreader truck or the water truck could limit that or be the controlling factor on how far you go. Based on 15 tons, 30 feet wide, with the spreader, you'd go 1,154 feet. With a water truck with 3,000 gallons, if you were adding 1% moisture, you go 1,800 feet. So in this case, your chloride spreader truck controls how far you go. This shows the chloride that's been spread, the water truck that's being pushed by in this case, a blade with a rotary mixer on the rotary drum on the front on the moldboard, and then followed by, rollers. And of course, all this is going to be, picked up again, but getting that compaction will speed up the process of curing. So, one of the issues that we have with reclaimers is uneven moisture content. This is a cement stabilization project, but nevertheless, it happens in all cases. Here we're getting a lot more moisture because of probably overlap between the run that came this way and the run that went that way, or there may be some problems inside the drum where part of the spray bar is blocked off. You can tell by the reclaimer tire, the amount of material sticking to the reclaimer tires is to just, you get too much moisture here, outside of the fact that you're sinking into it here. With respect to milling depth checks, a good way to do that is to, at the edge along the shoulder, and I'm assuming you have a pretty good shoulder out here, you basically remove any loose material right on the surface and then dig a hole and measure that depth. Here we're looking for 3 inches, and here again we're at 2 inches, and we have this 2-inch depth, and again here's our compacted depth that we're trying to determine whether or not we met that depth requirement. Here with this type of mixer, where we turn we turn nozzles off where we're overlapping. And again, you can do that in a cat reclaimer. 2 every 6 inches. They got a water bar. Here we're looking at moisture content indicators. You can do this by picking the gravel up in your hand and squeezing it. You should see some moisture on your fingers and palm, and the cast that you make should stick together. If it falls apart, you're too low. If you got if you're squeezing a lot of like mud out on your fingers and the palm of your hand, you're too high. You can also look at the tires on your reclaimer. A little tough to do on a cat reclaimer for the operator, at least, to see them. But and in this case, this isn't a really good example. This tire should have more fine sticking to it. But and I think I have a better slide here later where we look at the front tire on this type of machine, and it's clean basically with little material sticking to it. We're adding water in the drum here, so we got higher moisture content. You can see that on the wheels. Here's a case where the reclaimer operator starting out. He needed to ramp up his water as he got into material. That's difficult to do. I mean, you can't just turn on the water and expect it to be uniform, because you got different amount of material coming over the top of the drum. So anyway, we got a wet spot here, a dry spot where he totally turned off his water, then another wet spot, and this blade here is waiting because as soon as the reclaimer gets matched up with the first run, he's going to blade these wet spots out, and so we got some wet spots there. We got quite a bit of material sticking to the reclaimer tires. The moisture content looks, and the mix looks very uniform. We do have some overlap, higher moisture content at center line, and so the blade operator is going to have to solve that problem. Otherwise, we'll have problems probably getting compaction here because it'll be too wet. There's a good reason why in the specifications they call for to be 2%, within 2% of the low side of optimum. So if our optimum moisture is 6%, we have to be within 4 and 6, and we don't want to go over 6. And the reason for that is that, you know, to eliminate or reduce the amount of blending that we need to do with the blade, and hopefully meet compaction without it and not exceed optimum moisture. Again, this estimating process where we dig or put our hand into the, you know, the mixed material and squeeze it. You know, this material's too dry. You know, the clump is starting to fall apart. And this case, you know, we're close to optimum moisture. There's no sheen on the aggregate, and the material sticks together. In this case, we're squeezing too much moisture out of the material, and we see an excess amount of fines and moisture on our palm and fingers. Oh, here's a better picture of the tire comparison, where, you know, your tires show quite a bit of moisture on them, and your front tire that's doesn't. And seeing the back tires on a cat reclaimer is pretty tough from the operator's compartment. So that's where a ground man comes in. That's pretty important. We already talked about this streaking, and we talked about this problem. And you can also have segregation problems that exist because of moisture. So, you know, when you see these kind of problems, you need to figure out what's going on. And the only way, you can't rely on the reclaimer operator to see these. That's not realistic. I mean, there has to be somebody on the ground doing that. So, you know, with respect to the granular operation, I think, you know, the alignment, I mean, he basically has to follow the whatever spread in the way of chloride. You know, his depth control is, of course, important. And, you know, you don't want to get into our subgrade. Hopefully we've got enough rock out there. Sounds like we do. You know, moisture content is a big thing. And that will influence what happens, you know, during shaping and compaction. So that's very critical. Now we'll talk about blade processing, the gravel and chloride. You know, the objectives of this are to improve the chloride mixture and moisture content, okay? Make it uniform and help speed up curing. One of the things that we have these pretty wide roads. Here I show one at well, 16 feet either side, so it's 32 feet wide. And we have a 14M with a 14-foot moldboard, and you know, you can stack material higher than the 27 inches, but it takes up quite a bit of space. And so, you know, part of this, when you first move this material from this side to this side, part of this really hasn't been touched, and so you need to, you know, make sure that you get everything mixed. Maybe by making a run down each side, and then moving it all over to one side and then spreading it. Various techniques for that, obviously. But we need to process full depth and width, and that's what it says in the specifications. And so anyway, and you know, the higher the moisture content is, the more this is going to fluff. But the higher it'll stack too. So, so here are some of the concerns about, you know, doing this. But the segregation is a key. If you can't get this to a uniform moisture content and gradation, you need to keep mixing, and so that's important. And I guess you know, this is what the specifications talk about for cross slope. And again, we need a tolerance on this, and I would suggest, you know, making this 4 to 4.5%, and that'll give a little bit of leeway, because you don't really know, you know, how much that material is going to knock down after you build it at a certain percentage. And so I'd suggest building it at 4%, and you'll probably be just over 4. I mean, building it at 4.5, and you'll just be over 4% after everything's cured out. And again, using a slope meter and a blade can be real helpful. And the blade operator, of course, is one that directs watering and rolling. He's got to make it look right and come out right. And these two operations here are key to that. So he needs to control those. Another thing that's important is if you have, you know, like 1,000-foot run, for instance, and then another 1,000-foot run, you may want to wait until you get a couple of 1,000-foot done so you can blade all this out and make this come together, you know, with the crown and the proper crown and compaction and all that sort of thing. It's a little easy. I mean, the longer the run is, the more chance, or the easier it is for the blade operator to kind of make this look good. So, okay. And then compaction with the rubber rollers. Of course, you roll from the low side of the shoulder to the center, and should have a consistent pattern, but it's not near as important with gravel as it is with pavement. You know, the big thing with gravel is you can't over roll it, and so more rolling is better. So I wouldn't shut down rollers unless you had to for some good reason. The other thing to keep in mind is that increased speed reduces compactive effort. And again, if you're in doubt of that, you just put a nuclear gauge out there and run some tests after you run roller speeds at like 6 miles an hour, and then do it at 4, and you'll find that you'll get a lot better compaction out of 4 miles an hour. And the rollers follow the blade operator's direction, and never stop rolling. So, okay. Again, you know, this just shows rolling the shoulder, then the center line, and keeping these pretty close. And again, I think I already, you know, talked about these things. Generally in specifications, they specify 3 to 5 miles an hour for compaction rolling. And, you know, this just shows a couple heavy rollers. You will get increases in density with each pass, and you'll also get increases with traffic after you open it to traffic. But the tighter you get this initially, the better chance you're going to have meeting the 1/2 inch and 10-foot tolerance, surface tolerance. I want to talk about optimum moisture just for a minute. And optimum moisture is the best moisture for compacting material. And by best, I mean it takes the least compactive effort to reach density at optimum moisture. And during the first roller pass, you may get 90% density. Second roller pass, I'm sure you get 95 with the chloride treated gravel. Well, depending on the roller speed and all that sort of thing, but normally that's the case. And as you do additional passes, you get less and less compaction. You know, you gain less each time. And so if you were to roll below optimum, you may never achieve 95% compaction. And it depends on how far below optimum you are. At 2% below optimum, it's going to take quite a few passes to get there. And so I suggest you get within 1% of optimum, but that's kind of a close call. What you also find is that after you get done compacting, you will get additional compaction from traffic. And how much you get depends on a lot of different variables. But that additional traffic will not only compact what you did here, but it'll also make your surface tolerance probably worse. And so that's something you need to consider when you're, excuse me, just how long you're going to wait until after you do this compaction before you accept the surface. I mean, gravel roads are they're not pavement. They're not going to stay in the same spot forever. And so there is that problem with acceptance of that surface tolerance. And this is one of the one of the reasons why you want to try and exceed optimum, or excuse me, exceed 100% density, and you can do that with heavy pneumatic rollers, and that gives you a better chance of meeting the 1/2-inch surface tolerance and not having to worry about what traffic does to that surface. Okay, and then I say excessive rolling just below optimum moisture just make it easier to meet that tolerance. Finish blading, you're just trying to get the roller marks out, and you need to carry enough material on your moldboard to do that, but I wouldn't get very aggressive at cutting into it, because you're basically reducing the density and having to come back and roll more material. The finish rolling is very easy to get that back, because you've got a good platform here that's been compacted well. Transitions, between runs, you have to get into the last 50 to 100 feet to make a decent transition. So you do have to go back into what you finished bladed on the previous pass. And again, maybe using your articulation to help get that center line compacted well is good. After, in July, when you come back and do your finish blading, some of it might be dried back enough to where you want to put some water down, and that can help you, avoid segregation if you're using carbide pick blades, and also make that material compact well after you get done with your final passes. And of course, what you're looking for is the crown, and of course, after you get done with your final compaction, you're also looking for percent compaction, 95% compaction. I want to talk about building a road crust, which is not in the contract or the specifications, but it's a good way to try and reinforce the surface that you build with chlorides, at least with gravels that contain some clay. Now, so the sandy aggregate that we have in place, we're stabilizing. You may not be able to do this. I think it'd be worth a try to try it, but and most counties do this as a sort of a traditional practice, at least where they have clay in their gravel. And there's some benefits during construction. It does reduce the amount of raveling or float that you get off the finished surface after they're open to traffic, and it makes meeting this 1/2-inch and 10-foot surface tolerance easier. But again, the gravel should contain some clay. It kind of works best in hot weather because you get dry back pretty quick, and what you're doing is basically a light watering on compacted gravel, and so this light watering doesn't cause rutting in the gravel. It allows you to pump some fines for a road crust with rollers or water trucks or whatever, and the surface normally dries out and sets up overnight. So this clay crust is kind of what we're talking about back when I went through this slide here, and that I think that's an important part. It's one thing that's kind of difficult to specify in specifications, but I think it's quite doable in construction if you have some clay in your gravel. Okay, so here's a picture of Stark doing this, and these two guys obviously work together. I mean, this guy's backing up and he's watching in his mirror just how much runoff he's getting here, and he doesn't want to water too much, and otherwise you can lose some of the fines off the road surface into the shoulder. And this guy is pulling a pneumatic roller, and they're going like 5-6 miles an hour, so they're kind of whipping along when you consider going backwards. Here they're doing the same thing, and you got two rollers rolling, and normally, one roller pass will maybe not always do it, but a lot of times you can get enough fines pumped to the surface with running roller pass if the moisture content's right. 10-mile-an-hour signs put out for traffic will reduce the amount of pickup on vehicles that you get, and so that's something to remember. But what we're trying to do here is just get maybe a 1/4 inch of this material on paste on the surface. Sometimes it's not even that thick. It just depends on the gravel you're working with, moisture content. Here we got a little excess moisture coming off the road surface, and but you do get these little sort of wheel marks. I wouldn't. They're not depressions, but that all goes away by the next morning. Here, we are putting down a light application of water, and we're doing the same thing with a self-propelled pneumatic. And again, you want to use like high frequency, low amplitude, and fairly fast speeds there. And you can do this very, very easily, with steel, with the vibration. In this case, we have a case where we have some segregation in our gravel, and we have areas that just looking at them, and it's hard to tell by the picture here, but when you look, it's somewhat obvious when you get out there. You say, well, I bet that part of the road's going to ravel, and sure enough, that's what happens. Most of the water has gone down into this because there's more coarse material in this area, and they had pretty bad segregation problems on this particular road. But again, you're just looking for a thin road crust over the surface, and in this case, we may not have enough to actually make a decent road crust, but in this area, we pumped quite a bit of fines to the surface. And again, that what we're looking at here on this picture I showed it right at the beginning is a road crust that was developed by those practices, so holds up pretty well. Again, the finished blading is we put down we do light blading and maybe articulate to compact, and then with building a road crust, it's the light watering, and then the rubber at roller at 5 to 10 miles an hour, or the steel vibratory too is a real good approach. You can also use the steel vibratory to try and iron out some of the ruts you might get to meet the 1/2 inch and 10-foot surface tolerance. You can kind of use this road crust practice with a vibratory roller to try and get that or solve some of the problems that you have with that surface tolerance. Talk about problems in the finished surface here just briefly. One is a shadow across the road, longitudinal streaks, potholes along center line, longitudinal rutting, intermittent raveling, surface delamination, which we've already talked about, and a hump at center line. This is a Missile Road. I took this picture maybe a couple of years ago, I'm not sure now. I've got a culvert in the ground, and this is it's probably a week after stabilization. Pretty tight surface. We got a little bit of raveling over here, which is really nothing to be concerned about. But this shadow here is, I want to explain where that comes from. And this culvert is, well, it's closer to the surface than what the photo would indicate. Okay. But anyway, the cause, I have listed some causes and some fix options here, I guess. But what's going on here is that when you treat the road initially, you have your chloride treated layer up here, and when the air temperature rises, like in the afternoon, the chloride goes down, and in the evening it comes back up. Well, the problem is it's not coming all the way back up, and so what we end up with is a area over the culvert here where the chloride has gone down, and then it comes up, and it goes down, and it comes up. So there's an area over the culvert that doesn't have any treatment. It was treated initially, and there isn't any way for the contractor to really solve this type of problem. And if you put more chloride in here, it's going to do the same thing over again. So there's no remedy that I know of to solve this unless you have gravel itself that's at a higher clay content that reduces the amount of chloride up and down movement. Okay. Untreated longitudinal streaks. This can, I list some causes here like uneven watering, inadequate blade processing after reclaimer mixing, an overlap or skip between reclaimer runs. Most of the time, these kind of problems are going to be solved by this blade processing after reclaimer mixing, right? If you do a good job of that. So you don't want to skimp on doing that, because that could come back and cause you some problems. Various types of changes maybe to improve the water truck, and maybe alignment berms or something. If this doesn't improve after looking at it for 48 hours, and sometimes it can, then you need to remix the gravel, reblade, add water, and then recompact, which is intensive. Okay, this is a hard problem to solve, or at least and so anyway, if you end up with potholes, you're not going to have potholes right after construction, but down the road after you get some rains and so on, you may get potholes. And if you do have potholes like this, I'd encourage you to measure the crown that you actually have, and because most of the time it'll be under 4%. And so one of the causes of this can be the rollers actually during construction. They can flatten crown too, but most of the time it's truck traffic on that crown. And so one of the approaches to help this is to go to a higher crown and monitor rolling operations and maybe change your crown building practices and so on. So longitudinal rutting can be caused by these benches in the different thicknesses in the treated layer. Pneumatic rollers kind of take care of a lot of this, but that underlying shelf often that can come back and haunt you later. And so you can get those ruts develop, and you have trouble meeting this 1/2 inch and 10-foot surface tolerance. Yeah, we already talked about checking the mixing depth and adjusting tire pressure, and maybe our blade processing didn't go as deep as it should, perhaps. If we have intermittent raveling or washboarding, that's almost always caused by segregation. Low gravel moisture content when it's placed, that will cause rock to separate. And if you allow traffic over it before it's compacted, and even water truck application is another, uneven spray pattern and so on is another thing that can be a problem. Increasing moisture in the gravel will help reduce segregation. That's the biggest way, or the most convenient way to address segregation issues, and maybe better processing with the blade from one side to the other until segregation doesn't exist. We already talked about this, surface delamination issue here. Sometimes we get a hump in the compacted gravel at center line, and that could be because our moisture content in our gravel is a bit too high, and during the curing process, it's moving too much. You can see this on curves a lot of times, whereas this would be the inside of the curve. This would be the outside, where the traffic is moving material in that direction. We could have just too much material in one lane during finished blading, and that's something, that's why it's so difficult to finish blade one side of the road and then a day later and come back and finish blade the other side. You want to try and wrap up both sides of the road and finish blading in the same day. So maybe some conclusions from this would, when thinking back the last couple hours, we talked about developing a work plan and be prepared to modify the plan, of course, and plan around the weather. And, I think we probably have enough material for 4.5% crown, but during the break, Mark was talking about maybe, checking that out to be sure, which I think is a good idea. If you have segregation issues, it's probably water, and deal with that early. I'd get close to optimum, but be aware that when you go over, you're going to have some problems. And I like to use a blade to mark center line and shoulder, but that's just my thing, I guess. And cleaning out the reclaimer and check out the reclaimer and mix depth and so on. So reprocess mix depth uniformly, make sure there's a good job. That in itself will help you meet that surface tolerance and compaction. And I'd say never stop rolling. And you will see some sort of a crown reduction during curing. I'm not sure how much. 0.5% is probably realistic. And the steel wheel can help you meet that surface tolerance. And we talked about finishes in the road surface. So the last 2 modules will take maybe an hour, but I'm hoping a little bit less. But I guess it's time for a break. So I'll stop share here, I guess.
Thank you, Steve. And for our break, I'd like to just stand up and just take a 2-minute, really not being just ask if there are questions, comments from anyone. And again, you can unmute your mic and jump in or go in the chat box. Anything in this room?
Keeps covering the weather. There's a lot of variability in weather here in North Dakota. You can get weather that blows in, and there's nothing on the radar, and 20 minutes later, there's a big storm.
Hey, Steve, this is Brian Hall. One of the things you've been mentioning a number of times is the cross slope grade. And I know that you mentioned that at Malmstrom Air Force Base in Montana, they're using a 5% plus or minus a half. And you said you had some discussions also during the lunch break, and I'm just wondering, is there, the feedback that I got from Malmstrom when they were first developing that cross slope was that the more they could get, the better they felt they were going to be. And I think when they started exceeding 6%, the concern is that drivers were uncomfortable driving on it. The argument against that is that most drive down the center line anyways. But I was just wondering if there's any thoughts or as far as maybe increasing the spec on this particular project to increase that to maybe a 5%.
I would really suggest going to 5%. I think Malmstrom, or the missile road system there in Montana, I think they've kind of beat that to death. And Lee, and I forget Lee's last name. If anybody can help me with that, I appreciate it.
Boys.
Oh, yeah, right. Yeah, Du Bois. He could address this probably a lot better than I could. I would really question going over 5% because, well, you get a lot of complaints. I mean, you get a lot of times you'll get a lot of complaints at 4%. But 5% will definitely reduce the amount of center line potholes that you get, and reduce the amount of blading that you'll have to do. I mean, and that's a given. And if anybody questions that, I would suggest they go out and build some road on the same road at 4.5 and 5%, and you will see less defects in the higher crowns. But there's a point where, especially in the wintertime, 5% crowns, if you got truck traffic, they are going down the center of the road. And so, I mean, you have to be sensitive to that as well. So, it's kind of hard to put a set rule on crown, because it kind of depends on the traffic, the road geometrics and so on. So, but I'd encourage you to at least go to 4% and maybe 4.5 to 5, but I wouldn't go over 5 for an acceptance crown. A good question though.
Yeah,
For sure.
and I think what they were doing is they were trying to push the either prior to compaction or basically the finished product was at the higher end of that slope, the 5.5 to maybe 6 range, with the idea that that's slowly going to get pushed back down anyways. And then another problem that they had, which would go back to the road owners, is that the operators weren't maintaining that steep slope. And that was where a lot of times they were losing their cross slope just because of maintenance activities that went on after the fact. But I've talked to Lee quite a bit about that, and that's always been one of his things. It was one of his big items, is that if he could get that good cross slope and keep the good cross slope throughout the duration of the 6 years where we do our cycle, he felt that road would maintain itself pretty well.
I think I would be behind that 100%, and I know that the county crews, they're under pressure from their constituents basically to reduce the crown, and it's asking a lot, to keep blading that back at 5%. But I do think that you will get longer gravel life if you do that. But there's sort of there's a trade-off here, and I'm not sure what the right answer is from the maintenance standpoint. But I think the higher crowns are better. But yeah.
Steve, in the class here, we've got another question regarding weather.
Yeah, Steve, you covered several times that there's a problem with weather and if it gets rained on and all that. Given the nature of the weather here in North Dakota, I mean, we've got weather that can pop up in 15 minutes that you had nothing to plan on. What would you suggest the best way to fix this if it happens? What methods work better than others?
Well, yeah, if you get, too much moisture in your gravel, because of a cloud burst or, something you're not planning on, which is, I understand that. If you're working in July, you can deal with that. All right. Because you have enough hot weather following it normally, but you're going to have to, reprocess that and work that material during that hot weather, which is going to take more effort than you'd like, of course. If you're working in late August, it's going to be tougher to do, So that's why, they have that September 15th date and so much emphasis on watching the weather. But yeah, I know you can get caught. That's just the nature of the beast at times. But I think, paying attention to the Doppler situation is really key to that. Does that answer your question?
And then also, what would be the minimum time that you really got to get that pack down where you'd be okay with weather rolling in?
Now, the minimum time for what again?
That you could get that pack compacted in. If you met the compaction for the cure to set in, so you don't really have to worry about it after that. How long do you have from when you finish to really have to worry about rain?
Oh, I think, once you get your final rolling on that surface, I think you're good. It's, you know, because once you do your final rolling, I would expect, and it'd be interesting, you know, to check, but and I haven't done this, but to see what your densities are after you final roll. And I would guess you'd be right at 100% or greater. And when you're at that high a density, you're not going to get much water in that surface at all. Unless you maybe have standing water, which of course, if you have standing water, you got wheel ruts in it or something, you know, which you shouldn't have there to start with. But especially on a 4 or 4.5% crown, it should drain off. So, you know, once you get that final rolling done, I think you're good. Yeah. Yeah, good question.
How tender is it right after the final rolling?
So the question is, how tender is the material right after the final rolling?
Well, it's going to move, and that's why we see, you know, with like truck traffic on the surface, you see a reduction in crown. But you know, I'd say it just depends on you know, how much truck traffic you get right after you roll. You know, and I think these two gradations that you actually have to work with are going to perform totally different. You know, because one is sandy without clay, one has got quite a bit of rock in it with clay. You know, so definitely the one with you know, quite a bit of rock in it and clay is going to be, I think, a lot more durable and hold up a lot better than the sandy one will. I think the sandy one is really going to be a problem. Yeah.
I have another question. What about when the final rolling's done? Is it going to require maintenance for the blade to come back several times if we do have, you know, say local traffic? That you know, we're talking one of the roads is in the oil field, so we could have oil field traffic on it.
Were you able to hear?
Yeah, and you know, I don't really know, you know, how to answer that. I think that again, you know, the key to this is to never stop rolling, get that density as high as you can, and that'll make that as bulletproof as possible. But you know, I've often thought, just based on observations, like in the oil fields in eastern Montana, which aren't near as severe as those, you know, in parts of, you know, western North Dakota. But I've often thought that the truck traffic makes this so damn hard you can't. I mean, it is just not bulletproof, but I mean, it is really, I mean, like 105% compaction. And you may have a little bit of ravel, you know, on the shoulders, but that travel way is just as hard as, I mean, you have to use a jackhammer to get into it if you want to sample. You're not using a pickaxe. So. Yeah, good question.
Hey, real quick to add to what Steve said, that was Minot was finding the same thing, although they didn't have the same kind of heavy traffic. But once they had finished their final rolling, and they opened it up to traffic, it was even just over the course, and when they came back to the next day, there was a noticeable improvement just in letting the private vehicles drive on the roads. It just seemed to kind of set everything up a little bit better. And I don't know, sounds like Steve, you may have had a little more experience with the heavier oil type trucks, but at least with the smaller vehicles, it's actually kind of a benefit once you've got that final roll done, that it kind of helps those roads set up.
Ryan, where is the site you're referencing at?
This would all be at Malmstrom Air Force Base. So as Steve said, we originally started using calcium chloride over there in 2008. And a lot of, I think some of the specs that you guys are probably looking at are coming from that. They have, obviously they've got different aggregate material, different weather conditions, but they've kind of fine-tuned everything and in the course of doing that, they've had their problems. And that was something I was going to maybe add at the end of this, but you know, for both the road owners and the contractors and even the inspectors. There's a lot of people that we work with that have made the mistakes already, that if you guys have any questions, you can connect back with those people. We can set you up with the right people that you can ask those questions and hopefully avoid those mistakes. Because as a guy once told me, all of the lessons he's ever learned cost him, some more than others. And we've had some pretty costly mistakes over the last 10 years doing this. But in doing that, there's also a wealth of knowledge that's available out there. It may be particular to the conditions at Malmstrom, but a lot of it would translate over to you guys, what you guys are doing at Minot.
Thank you.
Yeah, great comments. Yeah, I think checking with others, your contacts is really important. Maybe a lot more important than, checking with me in this case. So appreciate it.
Yeah, one other thing I would add too is even from the road owner's perspective, Fergus County is probably one of the counties that does quite a bit of their own work on those roads and maintains them. Cascade would also, but Fergus has quite a few gravel roads, and they've got a lot of lessons learned. One of the things you kind of touched on, Steve, which was when they go out if they need to go out and do any kind of maintenance on those roads, any kind of blading, they actually wait till it rains. They have to wait until the conditions are right, which is usually just after a rainstorm, and then they'll go out there and then they can actually work the road. When we initially started putting down calcium chloride, the road owners didn't actually like it initially. And one of the problems they had was they couldn't work the road at all once it had set up. So like if you got a pothole or something like that, they would come in and just put down some rock and try to compact it in. That material would be gone in 2 or 3 days, because it's almost like trying to put rock into an asphalt road as a fix for a pothole. It just doesn't take. So after a period of time, they learned, the more proper way to be maintaining these roads. And one of those things is wait till it rains, and then they can get out there with the equipment that they had and actually kind of break up that top surface as needed and get it smoothed out and regraded to the way that they wanted it.
Great info.
Yeah, excellent. Yeah, appreciate that.
So Steve, if you want to carry on into module 5, that'd be wonderful.
Okay.
I'll let you know when your screen is up. Oh,
Okay,
you're good.
we're good? Okay, we'll talk about quality and quantity control and assurance, and the way this is set up in most specifications is the quality and quantity control is the contractor's responsibility, and the assurance part of that is the agency's responsibility. And one of the big things with this, especially on sort of a process like this that's relatively new, is that both parties work together side by side at the same time, and that way you can solve the problems and work through the process most efficiently. There's a task list I have here. It's just another checklist for road preparation, and we've talked about all of these things: the calcium chloride quality and concentration. We really didn't talk about. This is something that's done by certificate from the manufacturer. And you can check this. And there's various ways to check this in the field. With the 94% pellet, I've never had any problems with it at all. The calcium chloride application rate with that 1.85%, we talked about, these different processes here. And with mixing, 3.5 to 4 inches. The width, of course, is kind of variable because the existing roads, I guess, are variable. And getting a uniform gradation of moisture is very important, and the optimum moisture within 0 to 2% below optimum. And then compaction and shaping, we have that moisture content, percent compaction, the crown, and the surface tolerance. So these are kind of all of the tasks that are kind of outlined in the specs in one way or another. And with the calcium chloride, we called for a flake in the spec, and I'd suggest making some changes here. And people have already started talking about this. When you look at this specification, the type S is a solid. These are different percentages of chloride, and the class A is a flake. And so, one of the things to point out, regardless of what you do with here, is indicate that the payment is based on 100% pure salt. And a lot of agencies will end up putting that actually as a part of the verbiage in the pay item. Some suggestions here just on how to maybe fix this situation are provided. And again, the acceptance for the chloride is by manufacturer certificate, and then visual inspection. And if the material, if the pellet is clumping, you probably have a concentration problem because it's absorbing water and sticking together. So part of the tonnage that you have in that sample is contains more water than the 94% would indicate. Dry calcium chloride kind of looks like this, and before it's exposed to moisture, looks like that, and maybe 20 minutes later, depending on the amount of relative humidity, it pulls in moisture and becomes water droplets. And again, it can absorb like 10 times its weight in water, so it's very moisture hungry, so to speak. Laboratory compaction testing. And this is on the newly crushed aggregate. This modified moisture density test needs to be run both with and without 1.85% calcium chloride. The optimum moisture needs to be determined, and then we need to get within 95% of maximum, which is normally not a problem. And for the in-place material, it's basically the same as this. So these two paragraphs are kind of the same. And the only concern I have here is to make sure that that sample that these tests are run on is consistent with the gradation tests that have already been run, so you can assure yourself that that's a good representative sample. And those gradations, if you go back to slide 10 and 11, it shows those gradations. Existing gravel shaping to 4%, maybe want to have a discussion on maybe changing that. And in the spec, it talks about 0.04 of a foot per foot, which is 4%. And what I do for quality assurance and quality control is use a smart level and a 1 square inch, a 10-foot long aluminum tube, that's 1 inch square. That works pretty well. One of the things you don't want to do, I think, is put a lot of faith in the grade controls in John Deere or Cat machines, but that's just my take on the situation. And of course, you need to measure that, and after final compaction, and make sure that that's. And I'd measure it before final compaction to make sure you're close, and measure crown and gravel depth and shaping, make sure it's you're meeting specs. if you want to do a field test like this with geotextile, this is one way to check application rates. The machines or the spreaders that Oxford's used over many years have been extremely accurate. I don't think that's a bad thing to do, but if you are a little off, I'm not sure I'd change what the is indicated in the spreader truck, unless it's obviously not right. And you can tell by looking at it after you've done a test or two whether you're in the ballpark. But you can spread over these fabrics, pick them and pick up the material. Of course, you know the area of the fabric, and you can weigh it and determine what the application rate is. And we already saw this slide where we calculated the spread rate in pounds based on this is what's required. 1.85 times all these numbers comes up with 7.3, but that is based on that 139 pounds. And the actual application rates in this table are probably not correct because they're based on this assumed 139 pounds. So need to kind of adjust this accordingly. And if the spread rates are close to the range specified, in other words, between 7.2 and 8.4, I do a truckload yield test and continue to do that just to make sure. It's pretty easy to do to keep track of all that. So, we saw this slide before where we had the example truckload yield test, and the same table as in the previous slide, and we're well within the 7.2 to 8.4 range here. So it looks pretty good. And again, this is the heavy rate, and it looks. This looks uniform. You can drag a stick through it like you would for cement to see what kind of thickness you have out there. Sometimes it's tough when you get a lot of material on the ground to judge uniformity. So dragging a stick through it can help. It's much easier with a, top coat applications, which are, about 1/4 or 1/5 the amount of chloride put down. Again, the mixing depth check here, checking that depth at right when you start is a good idea. And you can check this on both sides of the run that he makes through the material, not just on the down crown side. And what you'll find too, the reason loose depths aren't really very good for measurement is that when the reclaimer goes through this material, it actually is a little bit thicker loose depth on the down crown side than it is on the up crown side, if you said. So that's why loose depths are kind of tough to use. Plus, you don't know exactly how much it's fluffing, which depends on the moisture content. And the final depth check you can make after mixing, crown building, and compaction. And well, let me back up here. What the spec calls for is a pre and post placement survey, which is, this can be done. I've never found it to be very, well, it's not very convenient and it's time consuming, but the accuracy of it is another issue, which, it should be accurate, but I would maybe steer towards doing some other type of test where you can get much greater coverage. Doing this very often is very inconvenient and time consuming. You can use a dynamic cone pentrometer, which is just a drop hammer type of test. And you can normally detect where you run into the underlying material by the rate of penetration after each drop. Another way to do that is just when you're doing the nuclear gauge and pounding the probe, through the material, you can normally find where you're running into that underlying material just by the amount of how hard it is to pound that probe into the ground. Surface tolerance check, the 1/2 inch and 10 feet. This is a little tricky in that, you'll see some areas maybe that don't meet this that you don't want to tear up, and I want to talk about that a bit. Some things to think about. Will water drain down crown or down the road? How large is the problem? You think the problem is going to get worse or better? And maybe you want to come back in 7 days and remeasure it. And you may want to put off making the decision until 15 days later. But, and you can go back out there and recompact that with water and heavy vibratory rolling. This is obviously a real tight surface, but there is a 1/2 inch here that's a problem, and there's a 1/2 inch over here. Now, from a practical sense, I'd say this 1/2 inch on the shoulder is not a big problem. This one over here, I'm not sure it's much of a problem either, because this looks so tight. I'd hate to tear this up because you're not meeting that 1/2 inch surface tolerance. But this is, I'm speaking from a standpoint of, and I don't have any contract authority here or anything else, so you want to take this with a grain of salt. But that's my take on this. In this case, on the other hand, I think this is going to come apart, and I think they got segregation problems. I think this needs to be picked up and relayed, and water added to it. And if you have to get into the other side, which looks good, so be it. But this is obviously a case where I think this is going to look worse a few days from now than it looks right in this picture at this point. Again, estimating moisture content. We showed this slide before, and this slide with the wheels, and the cat reclaimer is no different than any other. You look at the back wheels, you can tell about where you are with moisture content just by looking at them. And checking for crown after finished blading, and I would check crown before finished blading too, to make sure that your finished blading is right on track. And again, here's that list of tasks that I showed initially. I'm sorry. There we go. Anyway, but there's a lot to do out there, and having your ground man and your quality control guy working on this together is invaluable. Okay, so that's important. Okay, I wanted to go into Module 6, maintenance of chloride stabilized gravel. And, there's quite a few bullets here to cover, but we've already talked about a lot of this. And so I'd like to refer people back to this Module 4 in the construction procedure for these topics, and focus on, blading frequency, the maintenance blading of stabilized gravel, the practices for that, and talk just briefly about chloride surface applications, which may be something to consider as a remedy for not achieving the life that you expect or hope for. And I also like to thank the many counties blade operators that have contributed to this. I've done presentations like this for a long time, and they're most of what I have to share with you comes from those knowledgeable people that have been out there 8 to 10 hours a day thinking about this sort of thing. So there's many thanks to those folks. One of the things in the report that Lee wrote essentially is in these exhibits, and I'm not going to get into these too significantly. I this information and put it into a sort of a simplified table. And these are the 4 counties that have roads in Montana, missile roads. And here's the frequency for their untreated roads, and here's after treatment. Now, Cascade County has pretty low traffic. And so, in their, I think, 3-year period is when this study, 3 years, they didn't maintain their road at all. Now that's unusual because they have low traffic. In some of these other cases, it looks like they bladed half as much. Here's one that's 1/4 as much, and so on. the overall average is, you know, the amount of hours of blading per mile per year has dropped by about 65% or 2/3. So, you know, this is one of the reasons that, you know, the counties, of course, really like these roads. They take less blading, and they're also less dusty, you know, so, you know, lots of benefits there. With respect to maintenance of the blading and maintenance blading of the stabilized gravel, one of the rules is don't break the road crust unless, okay, you have these kind of issues like, you know, if your traffic speed is dropped considerably, you got a lot of potholes, you got a lot of defects, you know, so you need to be thinking about blading. And like was mentioned earlier, you know, the best time to do this is in the spring, because that's when you have some intermittent rains over a period of time that gradually raise the moisture content in that surface. That is almost impossible to do in the summertime with a water truck. And so anyway, that timing is really important. And of course, everybody's in the spring blading, but you know, for these stabilized roads, I mean, that's about, you know, one of the few opportunities you have to really do it effectively, and hopefully get the road crust back after you do that. And you know, sometimes your potholes and loose rock are a safety hazard. That's another reason to get out there. And sometimes people will, not necessarily in the Missile Road area, but in counties that have done this, they'll add chloride in the spring, you know, in areas that might need it. And summer blading, again, you try and avoid this if at all possible. And one of the things that you can do to extend the life of these treatments, and this goes for mag, chloride, dust abatement treatments, or calcium chloride, you can try some watering at night. And you know, the light watering at night, and by that I mean like 1,500 gallons a mile. You know, that can act sort of like a rainfall that will bring back your chloride treatments. But again, if blading is necessary, you know, pre-water at night, the day before, I would suggest considering fall blading when defects are significant and maybe the crown is flattened. This will actually reduce the amount of time you need to reblade these in the spring, or you may be able to avoid blading in the spring when you have a lot of blading work to do. And it will actually extend gravel life as well. You'll end up blading less rock, snow plowing less rock off the road if you have a good, you know, template to blade from. And just keep in mind, you know, that the less blading you do extends gravel life, and this road crust extends gravel and chloride treatment life as well. And trying to get that back, you know, is pretty difficult in the summertime. In the spring, you know, that's realistic to do. But you may need a water truck in the spring too, because you know you're not necessarily going to get your rainfall when you want it. A lot of times with stabilized roads, you'll see loose rock along the shoulder. We have like probably 2 to 3 feet of loose rock width on this road, and that's not a good reason to disturb this road crust. And this is what happens typically after construction. You'll see, you know, after you get done building these roads, you're not going to see any ravel here. This ravel comes from the traffic that further consolidates that road surface and beats that road crust into the gravel. You end up, some of that gravel in the surface of the road crust is going to get worn off. If you went out there and you dug a cross section through this here and over here and you weighed it, you'd find that all of that loose gravel out there accounted for less than 1/8 of an inch of thickness out there. It looks a lot worse than it actually is. So anyway, lots of causes of loose rock. Sometimes if you're crushing over 3/4 inch size rock, you'll get a lot more ravel out of it. If you got a poor gradation, low clay content, and if your gravel is dry or segregated during initial placement, like that one photo that didn't meet the 1/2 inch and 10-foot surface tolerance, you're going to have a lot more loose rock out there. The blade guy with the county can't fix all of this. This is what was built into the road surface that the blade guy has to cope with. So again, looking at the need for blading, it's usually not necessary until spring. Some counties have not even bladed in the spring for a couple of years. And again, don't break this loose, this road crust, incorporate loose rock. And, oftentimes I think that it'd be better off for this loose rock to be plowed off the road completely, so it wouldn't bother the blade operator so much. But that's just my comment. Spring for sure for blading, maybe fall if road conditions are favorable. And this is kind of a decision. Something you need to maybe think about. You might want to blade maybe a section of road up and see if that does save you some blading in the spring. And most of the time I think it will, but if in ag areas we end up with a lot of dirt sometimes tracked on the road, especially like during beet harvest in the fall when the roads, or sometimes when the fields are wet, they end up tracking a lot of material onto the road surface. This actually should be removed as soon as it gets on there. And one of the reasons for that is that if you don't remove it, it's going to be a sloppy mess once it gets wet. And also the chloride in your gravel will migrate up into that. And so getting rid of that as soon as possible is a good idea. And I'm talking about the day after it gets tracked on there is a good idea. So now with dusting, you might want to top treat roads that are previously treated. And what I'm talking about here is like a liquid mag treatment on it. And whether or not you do that depends on, whether you got significant residual chloride in the gravel. And you can, in the spring, you need to kind of make this assessment. And a lot of counties will do this before they order their chloride. They'll try and figure out how much chloride they actually need to use. And, if this top coat on your treated roads looks wetter in the morning than in the afternoon, the reason it looks wet in the morning is because you have chloride in that surface. And so maybe in that case, you don't want to add any chloride. And also, if you have a really good road crust in place, maybe you don't want to disturb that and add any more chloride to it. You might want to ask yourself about the weather conditions through the summer months. Most people don't know what that's going to be, but that's kind of what affects how long your chloride's going to last. The amount of mountain type of traffic. Normally, what your heavy traffic routes are, and those are going to be the ones that you're going to want more chloride into and maybe retreat more often. And maybe the availability of a truck driver and water truck for nighttime watering in late July and early August. And that can make a huge difference. And the value of the gravel versus the cost of the top treatment. Gravel's pretty expensive. Top treatments aren't cheap either, but the gravel is quite costly. And then again, your potential for unbearable public relation events is another, how you can resist those is another effect, or another factor, I guess. Some retreatment options that you might have is to in place mix more chloride with a blade. This is pretty significant. You can do top treatment with calcium or mag chloride. You can do the whole road, or you can do problem areas. You can add clay to your gravel, to the whole road or just problem areas. And so this, the clay is probably a pretty good investment because that's going to be there for quite some time if you chloride treat. And so that'll improve your chloride retention. Try extending chloride performance, like this 1,500 gallon a mile watering at night. And you maybe evaluate whether or not this is buying you much by treating a short area and not treating another short area. Spring blading to build crown. We often see a flattened crown in the spring, so we want to build that up. You might want to overbuild it and let traffic have it for a couple of weeks and then come back and trim it. And this is a practice that, and by trimming it, I mean not filling a center line, trimming that back to a little lower crown. This is a practice that a lot of people use for mag chloride treatment, where they want a good solid crown at center line where the potholes seem to always develop. And so they end up with a berm of material, the trimmings over here, and they treat the road surface and then spread this little berm back over the surface as blotter. So another practice for chloride treatments is to overlap them at center line where they get a lot of traffic. And, a lot of, like, if you watch trucks go down the road, a lot of times they're going to be on that crown or a little over it. You can add clay to gravel by a number of different means. But, and of course, the areas to do that in are where you have, the PI and the 200 is, that some of those is less than 20, like in the in-place stabilization roads we're going to do. And, if your stabilized gravel starts dusting by early August, you probably, need some clay in there to retain that chloride. There's a belly dump method and a water truck method that I put together, sort of one-page guides, and be more than willing to share these. That's why I wrote them. So we have, a guide here for belly dump method and another guide for the water truck method. So anyway, I guess the last part of this, module 7, and is on the conclusions, and I'll kind of briefly go through those. And I'm sorry, Dale, I noticed this stop share thing come up. Is that when we have a question? Is that? Are you there? Are you there, Dale?
I'm trying to find what happened. I don't know.
Okay, I did. Go ahead.
You certainly can try sharing again, or we can just talk through it.
Okay, you want me to finish up? Should I finish up?
Yes, please.
Okay, I'm sorry. All right. Okay, so we'll go through module 7 here on conclusions. At first, this morning we started talking about expected performance, and I indicated that these two sites here where we have existing gravel, we will have raveling and washboarding, but we should, with our chloride in there, we should see a decrease in the amount of raveling and washboarding. And, the way you can evaluate that is just to look at the gravel on either side of this particular stabilized segment and see, if the washboards show up earlier in the untreated area, okay? Not very scientific, but, kind of give you, it'll show that basically the chloride treatment will always show some advantages or some benefits. Now, how long those benefits actually occur or prevail is another question. And on this, sandy gravel, I would expect after the first rains you have after treatment, which, you know, and if you're doing the treatment in July, you may not get any rains until August, I don't know. But you'll see a significant reduction in benefits after the first rain, and that's because of chloride leaching. Okay, but those may be some things to look for. You know, the performance on sites D3 and C10, I think, would be considerably better just because of the gradation in the PI. But, you know, one of the real benefits of this whole project is to make that comparison. And, you know, I would encourage folks to come up with some, you know, ways to measure, you know, that performance out there. I guess you know, I think that, you know, this is, you know, the first work that we've done with these kind of materials, and we're going to become more proficient at this process and more effective at getting it done. And so if we look at the first work that we do, it'll probably be less impressive than some of the other work that we do later on. So, you know, if we're starting on the north end, say, for instance, of the sandy gravel, and we're sort of, you know, struggling with that a bit to refine our process, which is normal. By the time we get to the south end, I would think we'd probably be in, you know, pretty good shape. And so maybe the south end of that project would look a lot better than the north end just for that reason. And that's, you know, better construction practices. Again, performance measurements, I'd strongly encourage people to adopt some sort of a monitoring plan. It doesn't have to be very complicated or time consuming. On construction equipment, I think, you know, making some minor changes to water trucks and the blades, and maybe like the tire pressures for your reclaimer, maybe the spray bar nozzles, that type of thing might be something to take a look at. I would strongly suggest you look at some heavy self-propelled rubber rollers to improve efficiency. That's not to say you can't do it with the towed pneumatic rollers, but just a suggestion there. On the construction procedure, just the moisture thing is extremely critical. Building a 4.5% crown, or as suggested, maybe going even higher than that, might be something to think about. And with the idea in mind that you're going to see a reduction in that crown over a period of time. And you may want to think about when you accept crown too. I know it's always in specifications, it's always nice to put acceptance on the final result after everything's done. In this case, I'm not sure, you know, how realistic that is, because we don't know how much the crown is actually going to decrease over time. Might be something to consider in the acceptance part of this contract. You know, this blade processing of the mixed gravel and chloride is really important, and the moisture content that you have in that is, of course, really critical. And again, with rolling, I'd say nonstop is a very good idea to keep in mind, and that'll help you meet that 1/2 inch and 10-foot surface tolerance. On quality control, you know, I can't overemphasize the timely coordination between, you know, the contractor and the agency people here. That's absolutely essential. And, you know, building a relationship between those two people is part of this process. And I think that's working side by side. There's no substitute for that, for building that relationship. And again, you know, continually monitoring moisture, mixing depths, compaction, and crown is very critical. So, and then in the maintenance part of it, you know, the maintenance of anything can either make or break what happens. And you I don't know all the answers here. And maybe coordinating with Fergus County might be something to think about, to share notes with those folks. They have quite a bit of traffic on their missile roads, and I think a very good maintenance crew. But the key to the maintenance, of course, is to not blade unless the defects, are get to be severe, and spring and perhaps fall blading is good, is when to do that, and rebuilding that road crust is really important. That's why blading in the spring is so beneficial. So I want to thank all of you for the good questions, and I really appreciate the participation. I put a lot of time into this presentation, but I know it needs a fair amount of work. But any thoughts you have along the line for improvement or anything would be appreciated. And hopefully you won't be seeing these signs show up beside your roads. This was taken about 15 years ago in northeastern Wyoming, where the coal bed methane fields were driving people crazy out there. So I guess that's all I have, Dale. And again, I appreciate this opportunity.
Steve, we do have a question. What are contractors and consultants using to check the moisture content in a timely fashion? Speedy moisture tester doesn't necessarily work for everything.
Yeah, that's right. Speedies, actually test just a sand size material. And while most of the moisture is in that sand size material, there's also another 1% or so in the coarse material. And so a Speedy can't really do it. And I think that, you can, one thing I've done in the past is, coordinate with this lab that's going to do the moisture density test and have them put a bag of material at optimum moisture or have them put a sample in a Ziploc bag of the moisture material at optimum, so you can actually squeeze it in your hand and feel what it feels like. And you'd be surprised how well your senses can actually detect this. And but that's a non-quantitative means of, but it's quick, right? People have paid me a lot of good money as a dirt squeezer for this reason, okay, on stabilization jobs. And I hate to say, that's what I went to school for, is to squeeze dirt, but it's very, it's actually pretty accurate. You can become pretty good at this. And I know you guys that work in the dirt with your blade and everything, you know what it should look like when it comes off the moldboard. And you can do, and I don't get in machines, but I follow them a lot. And so, squeezing dirt is, or gravel in this case, is a pretty good way to do that. And it's quick. You don't get a number out of it, but that gives you some comfort as to where you're at. So that when the nuclear gauge comes along and it says, well, you're at 5.2% or 5.7, you can say to yourself, well, yeah, that's kind of what I thought. And that does work.
Thank you. Other questions? If anyone wants to type in the chat box or unmute their mic in the classroom here.
Hey,
Also,
Steve, this is Brian Hall again. I was just wondering, one of the issues they've had for Malmstrom is trying to measure calcium chloride after it's been applied. So this is years down the road. They're trying to determine how much calcium chloride is still left in the material. And they haven't really come up with a good way to do that. Have you had any experience with that, or do you know anyone that has?
This is, I know Malmstrom's been trying to do this, and I commend that effort. I think that's good. There's some issues and it primarily relates to where you take the sample for this test that you want to do. You know, and when you do it, if you take the samples in the afternoon, they're going to be a little bit less than they will be in the morning. You know, so there's, and if you take it in areas that aren't very well compacted, like on the shoulders versus areas that were compacted in the wheel tracks, you're going to see a lot more in the wheel tracks because that material, because it's compacted really well, sheds water and the chloride isn't leached out. So, you know, there's those kind of inherent problems. That being said, if you kind of keep that in mind and when you sample, you have a consistent sampling protocol for taking these samples, you can come up with fairly consistent results. But you know, it's somewhat discouraging because if you go out there like a year afterwards, you may find that the chloride content is half of what it was when you put it in the ground, right? That's not encouraging. But on the other hand, when you look at the road surface, you would swear it's all there. And so, I mean, it's performing well. And so, you know, you might ask yourself then, well, did we need to put 1.85% in there? You know, so, but doing a post analysis like this is, I think, the more we do of that, the more we'll learn about, you know, about what's going on. But you know, the problem is that the chloride will leach. It will go down. You know, so you know, go down below the gravel layer that you treated. You know, so I'm not sure. I don't really have any good guidance, I guess, to answer your question, Brian. But I commend people to try this.
Yeah, with the testing that they were doing, what they actually found, so this would be probably 5 years after application. As you said, visually, the road looks like the road does have calcium chloride in it. It's obviously there. You've still got the good compaction. You've got the crust on top. You've got almost zero dust as vehicles drive on it. But when they're testing it, it's showing almost zero calcium chloride in it. And one of the things that we're doing out there is, you kind of talked about some of the gravel loss, and I don't know if you've talked to Lee recently, but the last report we got from them is they're seeing almost zero loss over a 5-year period of material, to include fines. So what we're actually going to be doing is it's just a restoration. So it's a reapplication of using the same material, not bringing in any new material, and then reapplying the calcium chloride at a slightly less rate. I think they're going at like a 1.5%, assuming that there's something in there, even though their testing is showing that there's nothing in there, and then going with that. So that'll still, you know, kind of to be determined at a later date, I guess, whether or not that's accurate or not.
You know, that's really interesting. I have visited with Lee. It's been almost a year now, probably. And yeah, he was alluding to this, and I wasn't sure, you know, what's going on in the last 12 months. But, you know, I think there's a great potential to learn even more about this and just how to come back and retreat. And of course, that's where Maelstrom is at this point. You know, they've got I'm sure they have at least half the road system treated, and so part of that is in the retreatment process, which, you know, it's extremely encouraging. They do spend, you know, they focus on having gravel with clay in it, though. You know, so I mean that's a big thing, and always has been. And that, you know, they're paying more for that rock. But boy, you know, if they're, I mean, going like initially in the first part of the presentation, I mentioned they're going from a 1/2 inch to 1/8 of an inch. I mean, to me, that's tremendous. You know, I mean, just that alone. But, you know, and that was over like a 6-year period. But if it's even better than that, I mean, that's even more encouraging. But I do think that we need to make a pretty significant investment in getting our gradation at spec tightened up, and then also, you know, requiring some clay or by PI spec in there.
Thank you, Brian. Comments or questions?
Actually, if I can ask one more. So one of the pieces of equipment they use there, which I think does the same purpose as the reclaimers, they've got a grater that they replace the blade with what I would describe as a rototiller. And it's the length of the board. And as soon as they put down the calcium chloride in the flake form, they'll go through and with this, and it just basically mixes everything and kind of spreads it, I guess, evenly and gets it just mixed up well. I don't know if you had any experience with that, or if is there an advantage to using the?
Well, yeah, I think, you know, this mill raiser, as they call it, you know, that machine was basically built for this type of process, and some counties in you know, provinces and states have bought those, you know, for this process basically, and also mixing in bentonite and so on. One of the big advantages of that machine, I'd say two big advantages is that, you know, it's got a small drum, so it's got a you know, small void, but, you know, when they start out. But one of the main advantages is its width. It's 12.5 feet wide, so you can most cover a lane now, unless you have, you know, roads that are wider than 24 feet. You know, most roads, county roads, are 24 feet or less. So that width is a big thing, because you don't have to worry about the lips or the, you know, when you go through, like with an 8-foot wide reclaimer making 2 passes, you got that little bench in there that you'd like to avoid. The other thing is the depth control. You know, you have tremendous depth control with a blade just by the nature of the fact that you got that mold board that you can, you know, inch up or down or left or right or whatever. And so, you know, that, and they can add water to, and it's all calibrated, you know, just like a regular reclaimer. So you can, you know, fine tune the water content coming out the back. You know, lots of advantages of that particular machine. You know, and so I think for in-place mixing, that's I think it's probably the best thing. I guess if you were, you know, if your roads were really wide, my first question for counties with really wide roads is, why are they that wide? And most of the time the answers are they've always been that wide, or the truck drivers, you know, demand that they be that wide. Now, the reason the truck driver is demanding that is because there's usually lots of potholes in the roads, because the crowns are down around 2.5 to 3%. And they need that much road width to get down the road without hitting potholes. So anyway, you know, just a couple of thoughts there, but if you can narrow up your roads and define your ditches a little better, and develop 24-foot wide road of good solid aggregate that's not going to dust and washboard and ravel, I think people would like that a lot better than a 32-foot wide road or a 30-foot wide road that kind of comes apart. So just a couple of thoughts. I appreciate the questions there, Brian. You've obviously had some firsthand experience with this, and that's tremendous.
And thank you, Brian, and thank you for help back in 2018 as Mark was looking out to Montana for help. All right, we do have another question, Steve. Are counties that do not have the equipment or knowledge having to hire contractors for the future maintenance after the projects and the contractors have moved on? So how do those counties maintain this?
What, is the question counties attempting to hire maintenance out or?
No, so the question I believe is that they don't have the equipment. They don't have the zippers. They don't have the tillers. They
Oh.
don't have that. What do? Do they hire contractors?
Well, yeah, that's, and that's, I think, the, would be the typical approach is to contract out, what you can't do, of course. And there's, like in North Dakota, because of the oil fields, there's quite a bit of reclaimer contractors out there. And, most of those machines are 8 foot wide. Some might be 10, but, you're going to have to make a number of passes, but they can certainly do this. I mean, I'm very confident you guys can pull this off with a reclaimer. Another approach is to go to using a pug mill and throw it back into the crushing contract world, okay, and have the chloride mixed during crushing. And, counties have done this quite a bit, actually. And they've also added bentonite that way, bentonite and chloride at the same time. And, one of the advantages of that is that you end up with a stockpile full of rock that's, got all of the goodies in it, so to speak, so that, that material can be used. You can actually go out and patch these holes that you come up with in your treated gravel roads just by throwing some of this gravel in there. It's already got all the stuff in it, and it'll stick in the holes. And you can, one of the things like Richland County, they just in Sydney there, they did, I think in 2012, they did 60,000 ton crush with bentonite and chloride. And they used that material for maintenance rock for like 7 years. They were very stingy about it. They used it around all of their cattle guards, around all of their bridge approaches, so that they eliminated or significantly reduced the amount of potholes before all those areas where you zero out your crown, and that's where you get a lot of potholes. And they reduced a lot of their maintenance, blade maintenance, by doing that. And so.
Well, that helps a lot. In the interest of time, I'd like to call that the last question and do a round robin to see if our expectations were met. And Mark, I'd like to start with you. How did we do? Where are we headed?
I think it was wonderful. I certainly learned a lot more than I had, and I was glad that the military and Brian Hall were able to join us so we can get the Air Force's and the Department of Defense's view on it. Hopefully this new process has more uses than we're even aware of, beyond, this Minot Air Force Base area for North Dakota. So thank you, everyone.
Thank you for getting this started. Kent, on behalf of the DOT.
Yeah, I just want to thank everybody. I think we learned a lot today. Some things that we could do a little better maybe with the design of the next time, and I guess we'll see how the choices we made work in construction. But I'm excited to see the successful project. So thanks, Dale, and thanks, Mark, and everybody.
You're welcome. Ben, on behalf of WFW, Dr. Foster.
I thought that it was very good. I wish I caught the beginning part, and I had a lot of people stopping in my office, so jumping in and out, I was able to catch most of it. I thought that was really good, and I'll be probably going back through it as soon as you guys get the recordings finished. I think it'll make a really excellent training session for even some of my inspectors that I bring out there. And I really like the part about the QC and QA working together. And that's critical on all our projects. Make sure everybody's on the same page, working together, and making sure we're all seeing the material the same, and it ends up getting a lot less hassles out in the field. So,
Right. Well said. For this, the big takeaway should be that we all learn, we all grow on the same level, and we all work to have a quality product so that the contractor's making money we have a great product when we're done. That's what this kind of conversation, really, those are the fruits. So thank you for saying that. On behalf of the Air Force Base, Department of Defense, anyone?
Hey, this is Brian. I'd just like to say thanks to everyone. I know when we started, kind of had some of the same issues with the applications at Malmstrom, and education for all parties involved was very helpful. It was something that the engineers out there did, the design engineers did, and I think it helped both for the contractors, for the owners, for future maintenance, and also for the Air Force to understand what it was that they were getting.
Brian. Tom Oxford.
Yeah, thank you guys very much. I thought it was very informative, and it'll be nice to start the project with everybody on the same page. And I'd like to say I was out visiting Fargan's equipment here a few weeks ago, and I have complete confidence those guys aren't going to have any trouble with this job.
Well said.
So thank you guys.
Let's come in our room. So Terry, Max, that was very good. Thanks, Steve.
Oh, thank you, Terry. Appreciate your patience.
And Josh, Ryan, Connor.
There's a very good, lot of good information in there.
Very good presentation. It was a good presentation, but I'm almost spooked.
And that makes sense. But hopefully, everybody working together, being on the same page, it reduces that eeriness. It is the first one we're doing in the state. Our materials are different. Our weather's different than Montana. We're going to have to do some tweaking. You've got great partners on the DOT Federal Highway side. You guys are just rock solid as contractors. Complete confidence, like Tom mentioned. We're going to be posting this stuff. Thank you, Denise. Thank you, Dustin, for making this spectacular, flawless event. They're going to be grabbing it. We're going to post it so you'll have it to disseminate and use as a learning tool in the future. Our team, our LTAP team, not part of this contract, but we're going to watch it. We're going to see how it's performing to see what can be used, what makes sense to use. And we'll be tapping into you for that too. With that, I want to say a great big thank you. We're right at our closing hour. Last comments would be for you, Steve.
Oh, closing comments. Okay. Well, thank you very much for all the questions and the opportunity. And I truly believe that, you guys will make this work and have a lot less pain in the process than others in Montana had years ago. So I'm very encouraged by that. And I appreciate, again, the feedback. So that's about it. Appreciate it. Thank you.
Well done, Steve. That concludes today's presentation. Thank you, everyone, for attending. Safe travels and stay COVID-free. Take care.